were my PhD students, and they are now become professors. David Agbonle, a student in production engineering department, who made the final drawings of the book. Then Hesek Engineering Limited staff, technical staff who worked with me on the project. Then Mr. Sylvester Imaranu, who is in the Faculty of Engineering workshop, who provided the electrical support for this project. And my dear wife, Patience Osai, who is always by my side, is not here now. I also want to appreciate these persons who donated this book to some institutions. We have Oregon, Dr. Sonny Foronsho Kuku, the Ogbeide of Zabulan and former University of Benin Pro-Chancellor and Chairman of Council, donated two of these books on road to gear to the University of Benin. We have Mrs. Anita Otibu of Sustainable Energy for All. This a UN organization in Abuja, donated one copy of the book to Uniben. And then Professor Akofure Tagbenu, University of Witwatersrand in South Africa, donated one copy of the book. Professor Tagbenu used to be with us here in the Department of Civil Engineering. Then the Dean, Faculty of our Dean, purchased 2 copies of the book for the faculty library. I think those other 4 copies that have been donated were given to the university library. Then we have my dear friend here, Engineer Charles Osaro Onaisa, is of the Allegro Microsystems United States of America, donated 2 copies to 2 US universities. Thank you very much, sir. God bless you. And then Professor Ezekiel Agbalaba is Vice Chancellor of the Federal University of Petroleum Resources from Fopri, bought 2 copies of the book for his university, and many others who I cannot mention here who have supported this book in one way or the other. I appreciate them. And then Professor Moniwo Tanota, is he around now? Moniwo? Okay, he hasn't come yet. He's coming from Fopri. He's a very dynamic MNI. He's a member of the National Institute of Strategic Studies. He's in Fopri. He's a council member of Fopri. And he's a network facilitator and the author of Mentoring from the Front Lines, which is one of the books there. Some of the books that we have authored, they are there. If you are interested, you can have a copy by purchasing 1 or 2. The objectives of this presentation is to, 1, to spur us to do impactful work directed at solving local problems that could also be applied at the international level, and then to urge us to file for patents for such works instead of just publishing. We can patent and then publish, and then to introduce us to the new gear making method of rod-toted gears. Those are the objectives, the introduction. We find that engineering is the design, building, and the optimization of systems such as machine structures and processes by the application of scientific knowledge and mathematical methods. It's a very practical endeavor. Engineering is a practical endeavor, and so it easily lends itself to making unique new products or systems. They are unique, which have not previously existed, and they are called inventions. So engineers, they are naturally primed to make inventions, to have inventions, because it's a very practical area and where you have to apply science and mathematics to systems in order to build new ones or to modify them. So it lends itself to inventions. So this presentation, we are going to limit ourselves to patents, which give a legal backing to every registered invention. So if you have an invention, and then it is registered, that becomes a patent. So quickly look at what patent is. A patent is an exclusive legal right given to an inventor by a government over an invention that normally covers some years, possibly 20 years. so as to prevent other persons using that invention so that the inventor can exploit it and make gain, either financially or otherwise, from the invention. And then also, that patent, after 20 years, after the time has elapsed, is made available to the public. Which ensures that there is innovation and development in the society. If the inventor dies and he dies with his knowledge, it's of no benefit to the society. So that is why government, when they give out a patent, they have in custody the secrets of that patent, and then which can be released to the general society afterwards. How do you qualify for a patent? Just to be novel, must be a completely new and something that has not been disclosed to the general public before the filing date. So if you have a new system, process, product from your research, don't rush to publish it, but first obtain a patent for it. Because when it becomes published, you find that you can no longer apply for a patent for it because it has already been disclosed. The standard practice is a standard practice in developed economies, especially when a company funds a project. They will not allow you to publish until it is patented, until they have exclusive right to it before they publish it. This, the Omonigo that I introduced earlier, had something like that. A company funded this PhD project in the University of Manchester. They could not publish until they have to have patents on it. Then the second thing for an invention or whatever to qualify for patenting, there must be an inventive step. That the solution should not be obvious to a person with average skills in that specific technical area. So it should not be obvious, there should be some thinking that goes into it. And then it also must be useful, must be of practical value to society. The engineering patents classification will have the mechanical, aerospace and marine engineering, electrical and electronics engineering, civil, structural and environmental engineering, chemical, materials and petroleum engineering, computer science, software and systems engineering. They are classified into that category. Then look at the World Patents Ranking by WIPO, that is World Intellectual Property Organization. This data they were obtained in 2024, and you see that China has made up the list with 1,796, 738 patents. China is always leading in everything, always. United States of America, see the distant second position, 503,000. Japan, 420,000. Republic of Korea, that's South Korea, 296,000. Germany, 133. India, 76,000. France, 51. UK, 46. Switzerland, 41. Netherlands, 26,000. That's the first 10. Then I now try to bring out those in Africa. The four largest economies in Africa, we have Algeria, South Africa, Egypt, and Nigeria. Algeria has 1,117, South Africa 1,056, Egypt 756, but Nigeria has 47. They did not supply the statistics for the patent registration in the country. So we are very lax in these things. They couldn't provide simple statistics. That is why we are having 103 positions. Angola, Ethiopia, Cameroon, Uganda, and Mauritius, they beat us because we did not supply the statistics, which is very bad. Then these are the number of people of Chinese universities, Chinese Academy of Sciences, 78. I really don't know what that means. I need to find out Chinese Academy of Sciences. But if you look at Tsinghua University, 31,000, Zhejiang University, 21,000, Zhejiang University of Technology, 11,000, and the Dalian University of Technology, 7,000, or almost 8,000. So those are universities in China. These are the top ranking ones in terms of patent. But the next slide will show us Nigeria. This, you see, I did a survey in 2016 where I sent out about over 100 questionnaires to universities in Nigeria. And then only 4 universities replied. I think after a month or 6 weeks after, only 6 universities replied. The University of Ogbeide said they have 10 patents. The University of Rio, 8. Cumberland University, 6. They already have 3 of those 6 patents made into products, which is great. And then Landmark University, which is also a part of Cumberland somehow, it had 0, but they replied. It was a very new university at that time. And then the Federal University of Petroleum Resources, in which I was the vice chancellor at that time, has 0 patents. But today, these are neighboring universities. I didn't have the time to carry out that kind of extensive survey as I did in 2016, 10 years after. For University of Benin, they only have 2 patents. That's what we could get, 2 patents for so many years of existence. And then the Federal University of Petroleum Resources, they have over a 10-year period, jumped to over 60 patents. The Benin University, they said they have 2 in progress. They have applied for 2. So you can see how poorly we are doing compared to the Chinese universities. See, even the Dalian University of Benin, that is the list there, has almost 8,000 patents. And they see us. We are not doing well at all. I want us to dwell a little more on the relatively high performance of FOPRI in patent registration. You notice that in 2016, FOPRI didn't have any. But when I moved in as the Vice Chancellor, we brought into consciousness of the university the need to have patents. And then it was included in the conditions of promotion as we hammered it out, so that every patent had a maximum score of 3 points, while for a book chapter or journal publication, we gave it 2 points. And then the university pays up to now for filing a patent. So filing a patent, the university pays. And then the Vice Chancellor, along with other inventors, we kickstarted the patenting process by obtaining 2 patents in 2018. We'll see that shortly. By the time when I left in 2020, we had about 8 patents in FOPRI. But then the Vice Chancellor who took over from me, Professor Prof. and the current one, Professor Ezekiel Abahaga, I have to commend them for keeping the patent flag flying, as the university now has over 60 patents. And then, even as they keep having more patents, there is the urgent, I told them that there is the urgent need to commercialize the very viable ones so that they can become more financially stable. These are the list of my own patents. The one myself, Gede was a professor in the Faculty of Agri-Food Science, and we worked on the cliche processing equipment. There are about 6 of them in a row, and then we had to patent it. It was funded by Raw Materials Research and Development Council, and then we came out with a patent in 2017. So it's commercialized. We trained some persons, fabricators, on how to make the equipment. And then there's the second one, Zede, Ofalagba, Iwadede, and the FOPRI, because we work in FOPRI there, they have to have a claim to the patent. Smart multi-channel independent billing, single-phase energy metering system. Then the third one is Grizzly, Nafa, Otanocha, that's Omonigo, myself, eBay, Zede, and so on, the FOPRI and Hypertrans. This what we combined with a company on the Benin Saple Road, owned by Lebanese. We worked on it together to have diesel-like fuel from waste auto oil. And then the fourth one, Federal Republic of this is a patent rotating shaft in tube material dosing valve for gases. This for metering. We had a food processing factory where we had to dose the sachets that we're making with nitrogen so as to puff up and preserve the food the foodstuff inside. So we did this because we wanted to import one from China. It was so expensive, and we felt that we could do one by ourselves. Then the fifth one, Tanucha, Monigo, and all of us, so many of us, and the Federal University of Petroleum Resources, we had this sustainable 30 cubic meter bulk digester for energy. So this one was sponsored by a UK company. And then finally, the sixth one is the road to that gear. I will show you a copy of the Okay, so we want to now look at, we have seen about the invention and patents that to put us in the mood for this. This, especially, this is very special, but I will make it very, very simple for us to understand. We have the brief in there, case study of rotated gear invention. The one problem that we have, we find that gear making is a highly specialized art where you have to use high skills and very expensive machine tools to make gears, which is usually beyond the reach of most fabrication shops in Nigeria. So that when a machine fabricator in Nigeria wants to reduce speed, which you usually have to do, we have to go to the market, the Wode market, you get it in Lagos. That is a very popular place where you get used equipment. And if it doesn't get a suitable one, it may resort to using other drives like belts, like chain drive, which will alter the original design that they had before. So to overcome this problem, there should be, there is a need for us to have an easier way of making gears and cheaper way of making gears. So this was what gave rise to this work on rotated gears that has that patent, and then also that book that came out of it is a 330-page book on the rotated gears. That is the certificate for this rotated gears, and this is the book, which we have the physical book there. So what is a rotated gear? That is what it looks like. That's that, and let me just show you this. So that's a sample. This is the driving gear. Usually this is the driving gear so as to reduce the speed and then increase the torque. So if you do it like this, that's the gear. So simple. These ones, they are rods. These are 10 mm rods welded on this disc, the same with that. So the number of disc here, the number of teeth here, and this will give the reduction ratio. This over this will give you the reduction ratio. So you see, it goes very smoothly. That's the rod test. So, but this is an example, a schematic representation of that, where you have a properly sized disc of diameter D. Down for the driving gear, there is D1. For the driven gear, there is D2. Then it has correspondingly sized rods of diameter T, numbering T, that we have there. Then the rods are welded to the disc. Very simple. The advantages of rotated gears: ability to make functional gears where appropriate gear making resources are not available due to the following reasons. Even when they are available, this one is easier to use. Use of common workshop equipment such as hand tools, welding machines, without requiring expensive gear cutting equipment, and then use of simple standard steel stocks of rods and pipes without requiring special steels, and then use of simple workshop processes without expensive machining processes, and then use of common workshop skills without the high technical skills required in conventional gear making, and then the low cost of the treated gears. We are continuing the advantages. The rotated gear, there is a simple additive process whereby you don't waste. In conventional gear cutting, you waste material by trying to make the teeth and the spaces. You are wasting material, but this, you don't need to waste material. So it's a simple additive manufacturing process. Produces little or no waste. The minimum number of teeth on the rotated pinion, the driving one, can be as low as 4, if not even less. Can even have 3, or even 2, compared to 17 for the 20-degree pressure angle involute gear profile. That is the standard gear profile involute. Then the tooth rod can be made with virtually any shape. Can be round, this one is round, can be square, you will see some square, then it can be hexagonal, can be orthogonal, it can be ribbed. This is what they call the twisted, but ribbed rods, twisted rod as local balance. Then the drawbacks. The performance depends on good quality welding of the teeth. If they are not well welded, so we need a highly skilled welder to do that. We have many highly skilled welders all around, even roadsides. Then, except for no speed change transmission, that's gear ratio are equal to 1, rotated gearing does not obey the fundamental law of gearing, which requires that the angular velocity ratios of the driving and the driven gear be constant, as shown by theoretical considerations. If you look at the book, we derived it theoretically that the only time rotated gears will obey the fundamental law of gearing is when there is no speed change. That is when the gear ratio is 1. However, we carried out tests and find out for practical cases, the gears, rotated gears, they obey to a very large extent the fundamental law of gearing. We'll see that in the next slide. This is the test we carried out without equipment that we have to build ourselves. This is a gear angular displacement test rig. So let's take note of that. We always cry, no equipment, no equipment, no equipment. But I wanted to get results, so I had to design and make very simple. That's this one. It's just something like this. Then we will now put a gauge and a dial so that as you rotate the driving gear, that will move some angles, and which will be reproduced on the driving gear, the driven gear. So we carried out tests with this. I is equal to 1, gear ratio 1. That is what it obeys. Then even for the other gear ratios that we're having there, it essentially does see that they are straight lines. So it obeys the fundamental law of gearing. And when we did further, analyzed it further, theoretically, we find that the disagreement for very large number of teeth, for the minimum number of teeth of 4, and very large gear ratio, the difference the deviation from fundamental law of gearing is about 1.9% of the drilling of the pinion. So which is very low. So it can be used virtually in all situations. And then the amazing discovery I found here that I found it was unbelievable that there was no documented work on this type of gear maybe in the English-speaking world, I'm sure also in other places. I checked the internet, I checked everywhere. I was amazed that no documented work on this very simple system. And then we will see my supervisor, an 89-year-old supervisor who supervised me from 1984 to 1987 at University of Birmingham. See what he wrote. He said, "Dear Aki, I send my hearty thanks and good wishes to you for sending me notification of your book. The subject is an intriguing, novel idea, and you are to be congratulated on formulating it. I think engineers of a wide variety of backgrounds will be keen to learn of the performance characteristics of rotated gears," which he said he will. So congratulations from Trevor. So we're going to look at the types of rotated gears. This is the spur gear, that's the spur gear that we have there. That's the conventional, this is the rotated gear, this is helical gear, this is the bevel gear, this is worm gear, and then this is rack and pinion, and this is internal gear. So it has the equivalent, rotated gears are the equivalent of the conventional ones. The design of rotated gears from first principles. We have to first of all determine the number of teeth, and these are the equations for determining the number of teeth. And then you have to, the weld geometry, there are two weld geometries that we use: longitudinally welded rod tooth, where we weld across the width of the tooth. And then we also have the chamfered end welded rod tooth, where we are only welding the ends, and that is suitable for tiny rotated gears, like what do you call it now? Like welding rod, say the 2.5 mm. That's Professor Monica, I've talked about you, so you are welcome. He's on his way to Mozambique, Maputo, for the International Conference on Welding. So you are welcome. So these are the two weld geometries, but this is the one that is best, the longitudinal. But in cases where you cannot, when you have very tiny rods, like as I said in electrode welding rods, where you want to use that, you just weld the ends. It's not as strong as the one that is longitudinally welded. Then these are the rod tooth gear stresses. This is how, it's from this that we determine the gear tooth stresses. The first one is the Lens gear bending stress tooth model. This is what is generally used in gear design. All of that they derive from this Lewis gear, but even this rod tail also derives from it somehow. This is our own model for the rod tail gear, the bending stress model. So, because this has been made very simple, that the roadside fabricators, welders can make it. So there are design tables that we have generated, that we just go, say for example, you have a disc, 50 mm, that's the standard stock material, and then for tooth rod diameter D, 2.5 mm, gauge 12 welding electrode stick. So all you need to do is to peel off the coating from it, cut to size, and then weld. So that will give you the number of teeth there will be 33, whole number, which is great. So this is the design table generated. If you go to 50, if you look at 50 for the disc diameter, take it down, you have, I hope you have 33. Am I saying 33? Where is 50? 50, 50, 50. Okay. Is it 31? Okay. Anyway, what this does is that you can have, if you have a rod, and then you match it with the disc, you match it with a rod, it could just give you the correct number of teeth. But usually that doesn't happen. So what you do is to determine what that blank diameter will be, take it to the left and turn it down to the right diameter so that it will give you a perfect number of teeth. If the number of teeth are not perfect, you find that it will not mate, it will be jamming, it will not even work. Very important. So we go to the manufacture of rotated gears. The basic resources needed, elementary mathematics to determine the number of teeth from that equation we get. Then the gear blank diameter, D naught. Then the basic workshop skills, you need welding, fitting and assembly and machining optional. And then basic equipment, measuring tools, bench tools, angle grinder, cutter, welding machine, then lathe, which is optional. The gear parameters, the tooth rod is analogous to the motor in conventional gearing. And that is what it is. Then the gear blank diameter, you need it, and it's given by that. And then the circular pitch, you need it, is the same as in conventional gearing. So the tooth fixing, how you fix the teeth is you have, okay. Something fell here, where is it? Somebody put it. So tooth fixing, we can pass this round to see how it is done. Very simple. So if a tooth fix, let me quickly go there. That's what is being passed around now. Here, the disc, that's the inner core, is made of 10 mm stainless steel rod, and then the outer, the tooth rods, they are from 3.8 mm concrete nail. So we have made it so simple that the ordinary man on the street, the welder, doesn't have to bother himself. Well, you can use the rod, two welding electrode rods, the normal gauge 12, which is 2.5, gauge 10, which is 3.25, other like that, and 4 millimeter, and so on and so forth. You can use nails. So the tables that we have considered that the sizes of nails, metric nail sizes. So you have that, so that you don't need to bother yourself. So concrete nail, this 3.8 mm, you go wrap it around. There are 12 rods that go around perfectly. So you find that alternately we have the spacers that will give the tooth space. It's also made of the same rod material, but to make it shorter, because after you have done this with glue or rubber bands, then you now secure it with a clip or bending wire. So that you can now weld. You cannot weld this. You can tack weld now. You tack weld those ones that are coming out. While the inner ones, you leave them. You don't tack them. So after you have finished tack welding on both sides, then you remove the clip. Then those ones you didn't weld, that are the spacers, they will fall off, and then you have a perfect gear, so that it will mate perfectly. So that is being passed around. So let me go back. Okay, so this is tooth fixing, just as I've explained. Those are the spacer rods, don't wear them. And then after that, after tack welding and welding permanently, this is your gear. Tooth finishing, then you need to dress it with an angle cutter, so that where there are too much wear, you knock it off. Then you can heat treat. especially for warm gears, you need to retreat because of the severe friction that it encounters. Then these are some particular manufacturing tricks. So first, very important, you use the same tooth rod diameter to create the tooth spaces. If you don't do that, they will be jamming, it will not work. Then for this internal gear for fabrication, this is how we make it. We'll after fixing the teeth, the rods, with glue, then you ram wet laterite into it so that you can now tack well. If you just use only the glue, it will burn off, it will not work. So, then fabrication of spline coupling, you can also do for spline coupling. This is how we do it. Then fabrication of helical gears, you fix one end at the helix angle, then you now arrange the others using that as the format. The fabrication of bevel gears, this is how it is done. And then fabrication of worm gears. This is very exciting. I want to make worm gears, especially if the rod is thick. The one we use for a particular application, we have to use 6 mm stainless steel. So you need to fold this on the lathe. You hold it, you secure it, and you fold it. And then you weld 2 links together, weld them together. So that after folding around, you remove it, and then you can now disentangle the rods, so that at the end you will have 2 coils at the end of it. So it increases productivity of the system. So this is what we are looking at now. These are some practical applications that we have used. That is rotated rack and pinion, square. And these are made of square teeth. Square teeth. See? And then we use it to drive automatic gates. That jumbo. Okay, we use to drive automatic gates. That's in my house. And we have other 2 applications where we have. It's Sylvester here. Sylvester Maralu. So they have been working with me, especially on the control side. So he knows what I'm talking about. Okay, thank you. Then we also use it to, this is a dual drive, the Honda. You can use an engine to drive it. You can use an electric motor to drive it. And then that should be a high-speed motor. But we're using one gear drive, one gearbox. So of reduction 1 to 6. So if you want the motor to work, that is the lever, you push it there, it will engage, and then the engine will work. If you want the electric motor to work, you push it to that side, and the electric motor drives. So we use the worm gear, something similar to that, but it's exactly that. We use the worm gear like that. This one we are seeing now is a square tooth worm gear. You can have the hexagonal tooth, octagonal tooth, so now the round tooth is the normal thing, but we use the round tooth here, stainless steel rod, which we use. This one we did not treat, so after it didn't work for very long, the worm gear worn out, so until we had to retreat it. So we're almost concluding now. Effective research pathways for national development, which we need if we want to be relevant to the system as researchers, as lecturers. Our research should be should be focused on local problems. And we have to identify a local problem and then apply basic scientific principles to get an optimal solution, then validate the solution by application to a problem, and then, if patentable, obtain a patent and then publish, then commercialize or put to use in society. That is when we say our usefulness. Conclusion, I will go through this. As researchers, ensure that your research solves a practical problem that will alleviate Nigeria's problems. Note that our numerous problems are raw materials or opportunities to excel and contribute immensely to national development. Then 2, if you find that your research findings contain an inventive step, do not rush to publish in journals or conferences, but first apply for a patent on it. Note that when your results are already in the public domain, they can no longer be patented. After obtaining a patent, network with investors and others to commercialize it. 3, universities, polytechnics should obtaining patents from research works or staff very seriously with the intention of commercializing them. If commercialized, they will be a great source of internally generated revenue, IGR, to the extent that government subvention will pay out in significance to the IGR. Patents should carry at least the same weight as for journal papers in promotion exercise. Footprint gives a very high value to this. Owners of commercialized patents, including the university, will have significant financial compensation, which cannot be obtained from journal publication. Then finally, rotated gears are effective, low-cost gears that can be made in resource-challenged societies like ours. They should be exploited for our rapid development. They can be made by roadside welders for a number of applications. Thank you for your attention. God bless.
Thank you very much. Please, a round of applause more, please, for our Prof. A beautiful lecture that he has just delivered on rotated gears. At this juncture, I will give the mic. Okay, process. Prof. What? Please, for our online viewers, you have been requested to send your questions so that Prof can actually do justice to them. To his WhatsApp number, please. Then for our live audience that are here present, please, questions are invited for this novel work. Thank you.
Dean and the members of the faculty. Prof, thank you very much for this innovative idea about patenting our research works. I'm sure that the seed you sowed in Fukri has grown tremendously because it became an integral part of the promotion exercise. We have spurred some people to pursue that route. I just hope that such a recommendation can also be made here so that people can be more innovative in that direction. My little question on the rotated gears is that knowing gears and gear trains, in the case of your rotated gear, you didn't tell us anything about lubrication. And then you did not also tell us, you only mentioned heat treatments. We know that those gears, if you, except for now that we are having the auto gear system, most gears outlive the things they drive because of the level of surface happening in the gear tooth system. So that you find that the vehicle will die, the gearbox will still be very active. So I think that if we can talk about surface hardening the materials in question, it will bring more light to the life expectancy of this innovation. But I also know too that the wedding, which can be done according to me by any experienced welder, may have several defects unseen. And so that on its own will also reduce the life expectancy outside the surface hardening of the materials used in the gear tooth manufacture. I don't know if you can make some comments on this. Thank you.
Thank you very much. Thank you very much. I've just been told that I would ask questions, that is, you will ask questions, and I will give the mic to my dean to acknowledge. Please, we will take more 2 questions to add to this while Prof provides the answers. Questions and answers.
Well, good morning, everyone.
No, your hands up first. Let me give it to the dean.
You want to give it to Dean? Okay, all right. I keep going.
Sorry, there is no need to follow some protocol, but sometimes I'm not a protocol man. All right.
Yeah. Thank you. Good morning, everyone. Yeah, I'm from the US. I'm with the Allegro Microsystem. I'm an executive employee, an engineer. Started my career with Intel Corporation in the US. So one thing I want to ask, it's not really a question, but it's something to be aware of. So the area of patenting, if you want to patent any kind of invention, you need to understand that you don't want to infringe on intellectual properties or others. So is there a way that the university can teach people, brief ways in which they can apply for patents? So they have patent attorneys that can help them to make sure that they're not infringing, and different little ways in which they can accomplish patenting. I'm sure a lot of intelligent students have different ideas, but they just don't know how to patent. So how to bring it to light? So is there some kind of course that they can follow to get them to know how to patent stuff? So that's just a question.
Thank you. Thank you very much. Okay, my Prof.
Good morning, my dean, my professor, supervisor. I'm trying very delighted to be here to see the work we are doing even at this time. I've known you for many years and the work we do. The only thing I want to say, is that the issue of patenting is not actually very well focused here, because academic staff are burdened with so many work, and then they have to publish the number of publications and all that. I know, I have a friend in UK that told me that to promote academic staff, you don't need so many numbers. They want to look at the impact of what you do. I know because when you move to footprint, you were able to make the change and you made. If you were not in the driver's seat, you will not perhaps not be able to make some impact. But here in the University of Benin, we want to see if it's possible to drive this. Because I know many of my colleagues have this passion, and they also can make this impact. But by the time you now employ a person, you have so many administrative work, as well as academic, maybe in the next promotion is have battling to have the number of paper in the international journal, local journal, national journal. You will not be able to make impact like this. I have reviewed some work for footprint. I see the patent. When they sent one to me, I was surprised. 3 months or 3 points for a patent work for traditional journal, 2 points. And because of that, the enabling environment was provided by the management. People work towards that. So if there's anything we can do here, maybe you can suggest to us. Thank you very much.
Thank you very much. Thank you very much, Prof. So please would give the opportunity to Prof to. Okay. Thank you, Prof.
Don't forget the questions. And Ogbeide.
Yes.
Most of them. Okay, yes. Former Director of Works.
Yes.
Thank you for your observations. Very wonderful. No, I'm okay for that. Yes, heat treatment, surface treatment, very, very important, so that the gears will last long. So that's what I have mentioned there. Heat treatment, if you look at the book, they are there, that you need to do that. If you don't, especially for severe working operations, the gears will wear out very quickly. What was the other question?
Lubrication.
Huh? Okay, lubrication. Yeah. Definitely, that's a lubricated.
This painting that we are talking about,
The pattern.
the flaws in the wedding because of.
Good. Yes, lubrication is there. If you look at it, chapter 6 talks about making the gearbox casing and all that. So it's there. You need to lubricate it. Then the imperfection in welding, that is a very high possibility. But if you give it to someone who is an expert welder, you are likely not to have that. The ones that I've been using in my house is made like this for the past 4-5 years, no breakage. So if it's well done, it's well done. I think so. Then the engineer Narisa, who donated 2 of the books to 2 universities in the United States. I want to thank you again. In terms, yes, actually, I think Professor Monigo will be enlightening us on what exactly FUPRI does. It's a long time I left there now. So, but what I know, in my own case, I use an attorney. They are specialist lawyers in this area who know how to go about patent. You pay them and they just carry the headache on them and then they give you results later. So it's very simple.
Right. So,
yes. So that they will look at all the loopholes, everything, and ensure that it's patentable and you are not going to infringe on any copyright or patent. So that is done. So if anybody wants to do that, you need to. If you are using NOTAP is very slow. No, it's government. They will not provide information on that, just like Nigeria will not provide information on patents. So if you use the private person, it will deliver on time. Then Professor Amelene, I said how this can be done in Uniben. Is this something like that? So the management will need to do something about that. But what I will do, I will send a copy of this presentation to the VC. I saw him 2 days ago or so. And when I think so, is it 2 days ago or something like that already? The team was there. He knows about this colloquium. So I will tell him this is the outcome of the colloquium, and then I will suggest. But the problem here is that FUPRI is a specialized university. They are all science people, just science, technology, and maybe management science. So who can, especially science and engineering, can have patents, inventions easily. But maybe other people, other faculties, they kick against it, who cannot bring out patents so easily. So that's one problem. But I will suggest this, that it could be a kind of incentive for engineering and science and others. So I will do that. Thank you very much. I hope I have answered.
Prof. If you still acknowledge more questions, we still have. Let us enjoy from the fountain of knowledge. Thank you.
Thank you, Prof. I want to thank my dean also for organizing this colloquium and also for the beautiful lecture. Actually, I have a kind of problem and a question and also a concern. My concern is when you are, displaying the engineering classifications, for patents and all the rest of it. I discovered that agricultural engineering is not on that list. So what really happened? That is my concern. Then the other aspect is actually bringing to light what we have been seeing that looks ordinary, but you are now making impact out of it. I remember when I was doing my PhD in University of Ibadan, I work with toothed gears. But what I was exposed to at that time looked so ordinary that I didn't really know that something like this would come out of it. But however, I had an issue, which of course also you mentioned, the issue of precision. We are talking about machining that is optional. We are talking about which other aspect also we say is optional. But these are the things that actually added precision to tooth gears, most especially when you're working with worm gears. So how are you managing it or doing it with the kind of skills we have? Though we may have people around you that can do that, but in the general, we just people that will just join two iron together and just come up with a system and it becomes very faulty. So these are the issues that I have. Thank you very much.
Thank you very much, please. Okay.
The day, my great professors here, colleagues, I want to thank Professor Ogbeide, my mentor and former Vice Chancellor, my former Master's Supervisor at Philippine here, and the product of Philippine, first and second degree. Now, Omonigo Benedict Otanaja, MNI, Niba National Institute. I'm a professor of advanced manufacturing and sustainable production systems. All the questions that have been asked here are wonderful. I'm actually here because I'm more field-oriented, meaning that I also double as the managing director of a spin-off company with a Scottish company in Scotland. But I'm trying to push it to work. So most of the projects that we do have more of those patents came from Fukuri. Is that we try to, even at first degree level, when the project comes at the level of conceptualization, we ask, what problem are you solving? I know for engineers, most of our designs are bespoke. They are solutions oriented towards a specific problem. And that's innovation. Was able to make any, even though it's 1% addition to knowledge, is innovation. So the first step you need to take, yes, and I'm willing to help Unibet. I saw your invitation. But unfortunately, things are. So I saw your invitation after Prof sent it. Unfortunately, last night my phone crashed and I had to repair it. So I've been blind since until I got here. So the first thing is to tell what they call IPTTO, Intellectual Property and Technology Transfer Office. Note, if you have that, that's the first step. You already have it, and then you can start moving on. So that would be value addition to what Prof mentioned about. Engineers are usually, now we're having a backlash in Fukuri where the science people are saying, oh, the engineers are having a headway. But there's a way we can do that. Most of our research now are what? Multidisciplinary. So for example, we did something on biogas. And I even had people in works, non-academic staff, included the patent that we had because they worked with me. So that's why there's not too much planning. So most people had their patent after Professor Ogbeide came and left because it was industry oriented because of our mandate. Our mandate says provide the highest level of manpower for the oil and gas and energy industry in Nigeria. So for most of the applications I see here, Prof, I came here to understand because he sent me the book, I've not read it, but I scanned through. If you notice, he's talking about low costs. So, like my brother said from the University of Ibadan, when we talk about precision, there is a direct linear relationship with what? Costs. So he's talking about low costs. How do you overcome loads? Okay, with cheap materials. And I've been involved with what they call remanufacturing recently, and I'm happy to work with this part of remanufacturing. When you use old parts, raw materials are scarce, but there are parts that are still very well available in your junk yards and the rest of them, and you can do what they call remanufacture. What Prof has provided is in that direction. So what you need to work on are majorly the raw material, which he has mentioned, like 316, which you can easily get, and they are in perfect sizes, because we are going to jumpstart our manufacturing industry. So we don't expect to do it the way those who are already ahead, because we'll be using that template. So his focus is more on what? Low costs. For example, there is a plant in cocoa that has a thermal reactor, disruption machine. The imported sprocket from China was only one. And I asked the man, if this the owner of the company, big company, making white products from recycling of oil. So you have the thermal disruption which fits in all kinds of plastics, all kinds of tire. These are tire that you throw away. And it generates oil from it that is used to spike his crude to produce diesel and some other condensate and rest of them, and even HFP. But the sprocket that was brought in, wrought iron and everything, and I asked him, if this thing breaks tomorrow, this entire system comes out. What Prof has, I'm already seeing where I'm going to apply this. Tomorrow they call me, oh, this thing has broken down because we're trying to reproduce it. And you have to come with dead weights. So you can see where this application is going to. Low cost to overcome high load. The sprocket was supposed to move a very big reactor, okay, that is laterally aligned to turn it around so that every part of material that is inside can get the thermal. So please, Deanship, it's something we have to push if we have to be relevant to national development. Look at all the developed nations. I believe Prof have mentioned that. What is notable about all of them, whether it be Japan, Germany, Russia, China, America, is the number of patents they have. It's not the number of publications. So my argument is, why focus on H-index, which does not acknowledge patents? Why focus on Scopus when they can't solve our local problem? So the main thing is that let's use our local resources, especially those parts that are off. And then they can use, we can do remanufacture, integrating what Prof has brought on board to overcome some of our industry challenges. I thank you and I'm willing to support you. What about you?
Thank you very much. That was the next one. Okay. Let's take one more. So that Prof can give an advice. Where's the person? Oh, that should be the last. Okay, thank you.
The Dean and faculty, Professor Ogbeide, the presenter, thank you for the commendable lecture. For those of us who are mostly in the field, thank God, notably I have worked with Prof for quite some time, and I know you probably recommend me from where you're sitting down. I just want to quickly ask, the two-thirds judge, the raw two-thirds judge, is there limitations to the root or pitch diameter? What I'm trying to say is that if you go to things like toys, where you have micro gels, can we apply this to something like that? Is there limitations to the diameter that we can have raw two-thirds gels? Then secondly, can this also be applied to plastic or polymer gels, or we are dealing within the metal domain alone? Otherwise, can this also be extended to the polymer domain? Thank you very much.
Prof, thank you very much.
Thank you. Maybe I'll just start from the former US president when I was dean. Is it? Okay. So, yes, there's a limitation. For very small, like as you have in toys, and then plastic, I've not explored that, so I'm not sure it will work very well. So that's why we should see what my former PhD professor said. He said we need to know the performance characteristics of this new game making method. So we need to do that. So it's something that we can try in our research to see if it will work. What I know very well is that it should be, steel gears. Made of nice steel, stainless steel, and all that. But you can still apply it to aluminium. So metals generally can you apply it to aluminium, so on and so forth. For plastic, I'm not so sure about that. Then the young man, the question, you're talking about precision, how precise this will be. I think Dr. Monigo, Professor Monigo has already answered the more precision you require, the higher the cost. So we are looking at generally general application that we encounter in Nigeria, in low developing countries. So we are not talking of so much high precision. But then, if you are careful and you use laser welding, it's still possible to have good precision in this method. You have to use jigs and then maybe fixtures to be able to align the teeth very well. But the thing is that it has an inherent precision in it, in the fact that you use the same rod to create the gear space, the gear tooth space, so which is wonderful. So it has an inherent precision in it. But for very small components, I don't know. We need to try that. We need to try that. And then Anonimo has okay, what is it? Okay, yeah. Is there chemical materials and petroleum engineering? You have agricultural chemicals and all that. So it's there somehow. It can fall within mechanical or chemical. And most likely, if you are working with machines, that will be mechanical. It doesn't really matter. So let me quickly, before I go to Professor Monigos, there's somebody online question from here. He said, my name is Osezwa Benedict Mutinileben, Lagos viewer. Dear Prof, I have followed you right from being a student. You have done well for coming up with this rotated gear. My question is, can this be used in gearboxes? The rigors of the gear train is enormous. What is your thought about it? Yes, it can be used. We use it for, I told you that we use it to drive a dual drive yam pounder. Let me go through. We had a gearbox that was one gearbox. And yeah, a lot of rigor when you are using one gears. So there was a lot of wear. We have to now treat it so that it will be able to, to cope with the rigors. So that is the dual drive yam pounder driven with round stainless steel rod, 1 to 6, one gearbox. The work you can have. In the book, there's chapter 6, which discusses the design and manufacture of gearboxes. So you can take it very well. So I hope you can reach me again if you are not satisfied. Then coming to Professor Monio Atanocha, he said quite a lot of things, but I just forgot to mention that he is the managing director of Fupri Energy Solutions Limited. He has been the director, permanent directors, and have done very well. And this is a company that was floated by Fupri and High Flow Energy Limited in Scotland. And they have been working well. It's targeted towards the oil industry, and they are doing very well. So we need to have such initiatives so as to bolster the finances of the investor, and everybody will be happy. I think that's the much I can say. You need, I say IPP, or whatever, you have it here. Okay, but if you are going to have a patent, you better work with, what do you call it, patent attorney, lawyer. So then you liaise with the IPPTO. But no government, this is they usually waste time. And if there's no drive from the investor in it, they will not perform. So, but I'm going to give this lecture and make this point to the Vice Chancellor. Thank you very much.
Thank you very much. Please, a round of applause, please. A round of applause. For a beautiful lecture that has been delivered by Prof. No wonder we all have to leave our respective places and houses to partake of this fountain of knowledge. Thank you very much. So at this juncture, please, I'll call on the Dean for the closing remarks. Thank you.
Thank you very much, Dr. Mas. I want to stand to acknowledge my renowned and iconic professor. Thank you, sir, for this wonderful lecture. I want to appreciate everyone that taking time to attend this colloquium. We're going to be coming up with more of this. I was just eyeing Professor Ogbeide when he sat down, so they want something for the university. I'm sure she'll be preparing to come and tell us about the EVs. And so there's a company that currently building an electric vehicle charging station just behind the faculty. So we'll be actually very soon to come and talk to us. Some of them are doing us very proud out there in society. So I want to encourage everyone of us. The issue of patent, we are the way informed about the importance and what it brings to the table for a university, for a nation. It's so embarrassing that the whole Nigeria got 7, and then China is thousands of patents. It's as if we are breaking melon here, but we are not. But we can still wake up. You need to say anytime you wake up, it's your morning. So it's time that we wake up. So one more time, I want to thank our lecturer. So we are going to close now. The seminar hour is just 10 to 11. We're taking just 30 minutes in addition. Thank you for coming. HODs, thank you for mobilizing your staff to attend this colloquium. We want to implore you that whenever there's colloquium, HODs, you are to mobilize your staff to come and come in good time. Colloquium that starts by 10 is not used scrolling down by 11 or to 11 or after 11. You get nothing. So that's just my information. Thank you. We'll be ready to collaborate with Professor on Fupri because the engineering invention is not a one-man show, it's a collaborative work. And so it's time for us to really rise up and take the challenge and conduct research that could be good for patent. Thank you. I will now call on the woman. Let me call Professor Mrs. Ngozi Ojo to close for us in prayer. Thank you.
Praise the Lord. Let us pray. Father, we thank you for this colloquium that ended. We thank you for the life of Professor Ogbeide and all his team. We thank you for our team. We thank you for all of us lecturers in the Faculty of Engineering. Father, we agree right now that from today onwards, that we will do work that we patented in Jesus' name. Amen. As we live here, Lord, we are not living as if we're present. We feel God and hands of protection will be upon us all. Thank you so much for our family. Thank you for our work. We give you praise and honor. In Jesus' mighty name we are praying.
Amen. Thank you very much.